Okay. So basically, what I'm discussing is the test cases, right? Test cases need to have standard format. It should have a standard format always. So then, if we don't have a standard format, we can't make sure what we are testing is perfectly correct. And because the requirement is set up in a statement, so but we have to derive exact scenarios, combinations, and all those things based on those statements or requirement, and we if we need to repeat it, so we have to run multiple times based on our requirement, because once the defect fixes happen, we have to run repeatedly. So then you need to make sure same test you're running, and you need to present your status, number of test cases you run, number of test cases fail, and all this information. If you don't have this count of quantifiable testing unit, you won't be able to present that. So because of that, test cases are very essential for that as well, and even for estimate. I think there will be a future session for estimate, so we'll do a hands-on session on estimation as well. In that session, definitely you will see why test cases are essential. So you need to know what number of test cases you are going to write and how you are going to do. So because of that, test cases are very essential thing you have to derive based on the requirement before start testing. Right? So basically, there are two different type of test cases, right? So one test case is positive and another is negative. So positive test cases means basically you are validating application happy path. So think if you are going to validate a login page, maybe Google login or Gmail login or something like that, you have to enter your username, you have to enter your password, click on login button. So and then it will be logged to your email. So that is a happy path of the login scenario. So that is a test case. Log into a Gmail application using correct username password and making sure you log to the inbox, right? So something like that it will be your test case. So that's we call happy path or positive test case. But if you are going to test login page, I think testing that will only not sufficient. You might have to do a lot of negative testing. Basically, negative testing is you have to use incorrect username, incorrect password, username with different characters, different special characters, different multiplied characters, and pass name with various combinations or very simple password, different complex password, something like that. All these things you might have to use, and my negative values, minus values, and all these things, right? You can have large amount of values, right? Different values. So you have to test. All these will be negative. So as when you are testing, your outcome will be your username is wrong, your password is wrong, or you can't use invalid characters or something like that. You will get an error message and you won't be able to proceed. Since you are supposed to get error message and you are not allowed to proceed, we consider as a negative test case. Right? So basically, we'll have a positive, negative. So that's a fundamental area. Right? So before moving to that, so this is a sample template how we are writing in test cases industry. Basically, we will write it as a table. In a table, we will have test case ID that is which is mandatory. We should have unique ID always. Then we need to write a test objective, what we are going to test. So basically, email address is a mandatory field for login page. This is some sample, right? Then precondition. So if you are going to do this, what are the preconditions? Basically, you need to have a browser and you should have opened the login page, something like that, right? So steps, you enter the email address to the username field. So if we have multiple steps, if you need to enter username in this format, and you need to click on login button, you need to click on cancel button, and all this comes as a steps. And then you need to mention your expected result. Expected result is what is expected by performing this activity based on the requirement. Right? So green color tick should be displayed, something like that, right? So here, so if you are entering a correct email address, you will get a green color tick, or you will get a green color username or something like that, you will expect. So actual results also another column that we will only measure when doing the execution. So it will only happen at the execution level. So I will tell that little later. Basically, this is a basic template you will have to use if you are writing test cases. Right? So, and there are certain conditions. So, where how we are going to write. So one clear thing is you need to very clearly write the test cases. Anyone who don't know the application or anyone new to your team should be able to read it and understand and execute it. And it need to be correctly verify the requirement. Your test case you should very clearly validate your requirement and expected results and all those things need to mention. And you should be able to easily determine the results, and it should be maintainable, manageable, reusable, and there are many characteristics we should have. So basically there are many attributes. These are very few, but if you are using test cases, if you're writing test cases, there are many attributes that it make it good test case, right? There are a few I just mentioned, but you can learn it by Google different various way. I'm not little deep down because these are very basic stuffs, right? But basically, I just want to give an intro about the test cases, right? So before I move into the set of areas. So the next problem is, so if you can write test cases, right? If you can write millions of test cases if you want, right? If by looking at a requirement, if you have been asked to test Gmail, you can write thousands of test cases very easily for each page and each UI, each functionality, each login, and many test cases. But problem is in real life, we don't have we don't have a luxury of writing millions or billions of test cases because we have to execute and make sure we release the application to the live environment without any issues. But same time, as I mentioned last week, right? If you leak any defects because of we are not writing correct test cases, that's also a problem. So that's a problem. That's a challenge as a QA engineer or software testers will have always how to write minimum number of test cases that making sure you are not having leakages. Right? You can't have leakages, or you can't have defect leakages at the production, but you have to write the test cases and execute. But you can't same time you can't write millions, billions of test cases to make sure the coverage because you don't have time, you don't have effort, you don't have people, you don't have money for that, right? So basically, you can't do that. So that's the problem. That's the problem we have to. So tell you one. So I haven't seen one project in past one of my past project. Actually, it's not my project, but I have been asked to go to a project and see what the problem the leadership has identified a problem of a project. So it's actually ferry application. So it's like the ferries are running between. We know that, so we have the English channel in between UK and France. There's a channel we call English Order. So there are ferries are running in this both countries. So at one point, so they have a project to develop application for these ferries, right? So but that project was not running well. So I have been asked to go there and work with the QA team and see what's the problem they have faced, what's the challenges they have, what's the struggles they have. So I went there when I meet the team. Very first question I asked, how many test cases? So they are in the part of execution, right? So actually the project supposed to go live within a 2 weeks time. I think almost 1.5 years, sorry, 1.5 month or 2 months, they have executed their test cases, and within 2-3 weeks time, they are supposed to complete. So I asked, how many test cases you have executed, you have written? So they said 90,000. So team actually leads, they calculated their modules and they say they have written 90,000 test cases. I little worried as hearing it itself. So then I asked how many test cases they execute. So I think almost 2-3 months they utilize and they could only execute 40% of it. It's somewhere nearly 40,000 or something like that. Out of 90,000 test cases, they have executed only 40,000, but only we have 2-3 weeks to complete the testing. So that's a fundamental worry. And I asked, well, how did you write it? So they have utilized maybe the 3-4 months unconditional work, 24-hour work, right? Over the late hours, weekends, they worked and they have written this number of test cases. So I asked, how did they write? So basically, they said they have a large number of requirement documents. So by going through each and every step, we wrote test cases. So that I think what they have done is perfect. So what they have gone through each and every spec point, minor detail in this requirement, and they have written test cases. But problem is they have ended up with 90,000 test cases that they never complete execute. They never able to. So that's a problem. So that's a usual problem any software tester will face. It's like this. So even in a war, right? We know. So if you look at a soldier, right? We can give a soldier to a maybe uh, multi-barrel launch set of multi-barrel launchers and ask to get few enemies. So you can use all these multi-barrels and you can blast the entire area and you can get that few people, few enemies that you want, like that what is exactly happening in Gaza, right? So you can do that, right? But problem is but if you want to get that, you have to kill rest of all other people and you can demolish everything. It's like this. You can write millions of test cases and you can get the few defects definitely available, but it's a waste. Or either you can use a machine gun and go to the place and maybe go to the room or go to a place and fire it for all the people and get one or two enemies. But again, it's worthless, right? Because you're firing maybe hundreds of people in a public and trying to get one or two enemies. So that's also possible. Or you can have a sniper and correctly identify the enemy and get his head. So just one bullet. Right? So what if you looked at all three cases? So using a sniper and get the exact enemy is perfect, right? Because one bullet, one person, maybe small time, no harm to everybody. Similarly, same concept will apply for testing, right? If you want to get exact defects that you have, you need to have bare minimum test cases to catch all these defects. So that's the challenge, right? Ideally, if your test cases has all your test cases has a defect, that's perfect. Like you are a sniper, right? You can get much value of your bullet, but that's difficult. Industry standard is we expect 10% of test cases should have defects. So at least you can write test cases, making sure 10% of your test cases are having a defects. Then you are doing a good job. But problem is how to do that job, right? How to make it scientifically. So that there's the place that is design techniques are coming in. So there are certain design techniques we can use to have minimum number of test cases for making sure all defects, capturing all defects. So that's where text design techniques coming in, right? So before moving to design techniques, I would like to get a few clarification categories and few areas. So there are few categories of testing. Basically, there are actually four categories of testing. One testing is black box testing. The other one is white box, and third one gray box. In addition to that, there are something called experience-based testing as well. So exploratory testing, something like that. So what we'll see what is black box. Basically, QA engineers will do the black box testing because they will not look at the code. They only looked at the requirement and derive their test cases and test it. So we call black box. Without knowing the code, they do the testing. So basically, your QA people or testers are not allowed to look at even a code, and they are not even allowed. They are not even given the access to the code. Right? That's a requirement. So they are doing black box. They basically look at the requirement and simulate the scenarios and do the testing. So that's what we call black box. But same time, developers also need to do the testing that we call unit testing. That by looking at their code, they need to validate their code that we call white box. Because while we are saying white box, we are looking at the code and we do the testing. But there is something called gray box. Sometimes it's combination of black box and white box. Sometimes some exposure to the code will be given. So sometimes if you are doing the API testing or some kind of gateway level testing or something like that, sometimes you might need to have access to some set of codes. Give me a second. Okay, sorry, a small distraction. The last one is experience-based testing that we call, sometimes we call exploratory testing. The basically based on this basically experience people will do. If somebody is a banking expert, he can, based on his knowledge of the banking, he can do the application testing without even looking at the requirement. So that's we call experience-based testing. So that's a different type of testing. So these are the different type of testing we have in the industry and anywhere where people will use. So black box, when it comes to black box testing, we will use these design techniques. Basically, there are many design techniques, but basically there are basic 5 design techniques we always need to use to derive test cases. If you are going to use design techniques, you can have the minimum number of test cases for make sure you are not have the repeating multiple test cases, or we have better minimum number of test cases. Right? One is equivalence partitioning. So other technique is boundary value analysis. The third one is state transition technique. Fourth one decision table, and fifth one hierarchy. Okay, let's see each of these one by one. So equivalent partition is, so I think, so we are actually partitioning the entire requirement into equivalent portions and identify the test cases. So basically, think uh, think if you uh, uh, have a scenario like, think if conditions. So think bank. So I will take example like, so if we are using internet banking application to open a fixed deposit, so think fixed deposits will have multiple interest rates. So based on your age. So think if you are a minor, if you are a below 12 years, your interest is 12%, so 10%. So we'll take it as an example, 10%. So if you're a regular adult, or if you're a regular banking person, age between 12 to 60, your interest rate will be 8%, something like that. These are hypothetical numbers. And think if you're a senior citizen, above age 60, right, your interest is high, and if you get a 15% interest. So interests are like that, right, in the banking. So think you are going to open a account and using internet banking application, and they will ask your age. Based on your age, they will decide your interest rate. So basically, so based on the age, so if someone account is opening someone below 12, so his interest will be 10, and if someone in between 12 to 60, different, the 8%, and above 60, 15%, something like that. You will get there. So if you have been asked to test, so ideally think if bank decided, so if usually we decided 0 to 120 are the different ages they will come across, right, by years. So the bank has application developed, it support 0 to 120 years of age. So basically, if you are going to test this kind of scenario below 12 and in between 12 to 16 and above 60, within 100, 0 to 120 criteria. So ideally, you need to write test cases from 0, 1, 2, 3, 4, 5, 6, and up to 120. Ideally, if you want to test whether the application is working for each age by years, you have to test 121 test cases, 0 to 120. So that's ideally you need to do that. But so what equivalence partition saying is, if we are going, if there is a, if like this, there are partitions below 12, in between 12 to 60, and above 60. You don't need to write 121 test cases like this scenario. You just can write one test case for each partition. So below 12, you can have one test case, maybe age 10 or maybe age 8 or something like that. In between 12 to 60, you can have another one test case, maybe age 30 or 40 or something like that. And above 60, you can have another test case. Basically, by writing 3 test cases, you can cover this entire requirement. So that's the equivalent partition. So rather writing 121 test cases, you can just have 3 test cases. Right? So that's what equivalent partition. The boundary value analysis is, I think, same scenario, same example. You can find boundaries. 12 is a boundary, 60 is a boundary, because but there are sharp limitation. So 12, below 12 there's a 1 percentage, 12 and above is another percentage, below 60 is another percentage, 60 and above is another percentage. So those are boundaries. We have two boundaries. So in ideal scenario, to cover these boundaries, you need to have 0 to 120 test cases. But if there are boundaries in your requirement, so this boundary value analysis technique, what they are saying is, you can rather having 0 to 120 in this case, you can write for three test cases for each boundary. Basically, what they're saying is n minus 1, n plus 2. This is the test case you want. You can write test cases for 1, and so then 12, it's 12, n minus 1 is 11, this is n plus 1, no, n plus 1, so 13. Basically, if you are going to test a boundary, you have to write test case for n minus 1, n plus 1, basically 12, 11, 30. For 60, you need to write 59, 60, or 61. So these are the three. So you can have 6 test cases rather writing 0 to 120. So basically, if you are covering for the same scenario for both boundary and equivalent partition, you need to have 9 test cases. But reality, you can write 120 test cases. Rather writing 120 test cases, you can write 9 test cases and complete it. So that's how the boundary value analysis will get the value. Right? Okay. The third one is state transition diagram, transition techniques, right? So this is basically, so the previous scenario I mentioned, so ATM. So there are, if we are trying to test ATM, so each step there are negative scenario as you can read the card. If it is success, it will continue. The card is cannot readable, it will reject. So if you are entering the pin, if it's correct pin, it will continue. If you are putting incorrect, it will cancel. So if you are choosing the transaction, you can continue or cancel. So perform the transaction and eject the card and end. Or you can go back to the previous activity and do another transaction. So various state, right? If you're writing test cases for such a scenario, you can write millions of test cases. But if you can draw a state transition technique, a state transition diagram, you can find out the minimum test cases. In here, your test case count is this. Here, this is one test case, and this is another test case. 2. This is another test case. 3. This is another test case. 4. This is another test case. 5. Basically, if you can draw a diagram like this, you can find out the minimum number of test cases rather writing thousands of test cases. So basically, the happy path and each reject states, you can have a different test case. So basically, by having a 5 test case, you can test 80. Right? So state transfer diagram says that. So it's make your life easy. Okay. So the fourth one is a decision table. So basically, decision table is you are writing a table that has a decision. So if you looked at username password scenario I mentioned, Google login. So there will be various scenario whether you can give incorrect you can write incorrect password, false, incorrect username, incorrect password, and you will not be allowed to enter. You will fail. Right? You can have correct password, correct username, incorrect password, but still you will fail. It will not allow. Or you can have correct, incorrect password, false password, correct, incorrect username, correct password, but still it will not allow. Or either you can have correct username password and it will allow. Right? So you can draw a diagram for rules, each rule. In addition to that, if there will be more rules. So if you are trying three continuous incorrect passwords, your account will get locked, right? You can write it three incorrect, another two incorrect, and the fourth one locked. You can have multiple rows like this, multiple rules, and you can find out what are the number of test cases required for this kind of logic. So here it's four test case 1, 2, 3, 4, username password both wrong, username correct password wrong, or username wrong password correct, username password both correct. But you can try the third case, you can try three different times and you can go for a lock scenario as well. That you can have multiple scenarios like this. So this is what decision table. Basically, you will draw a table based on the decisions, right? Based on the decisions, you have to do that. So last steps is error guessing. For as I mentioned the very previous one, so each negative test case kind of error guess. So basically, if there are positive test case, you can have a negative test case as well, making sure you are not allowing correct values, you are getting error message. So this is kind of a guessing, but each positive there should be a negative test case for errors. So that's another technique. So if you have 100 test cases, definitely you have 100 negative because you will have errors for each. Sometimes it might not be there, but you can look at whether there is a error message for each positive test case and write a negative test case. So that is another different technique. Basically, these are the 5 key basic techniques we use in software testing to derive and have a minimum number of test cases. Okay. Any questions? Anything to clarify on this so far? Okay. So then let's move the areas. So other concept what we usually use in industry is a mind map. We derive mind maps. Mind maps is a graphical presentation of a requirement. So basically we use a kind of tree, and writing this kind of mind map, we can make sure all the combinations and all the topics, all the requirements are clearly covered. So before writing a test cases, we can draw a mind map and visualize the requirement like this, and then you can convert them into a test cases. So that's another technique we use. In addition to that, there are another technique actually I'm not covering right now. There's some technique called pairwise technique. So pairwise technique. So pairwise test design is an algorithm-based technique. If you have large amount of test cases to write, you can use pairwise combination to make it minimum point out. Basically, it will compare by pairs. Think if you have various conditions. So think if you are going to buy a car, you have various conditions to compare. So car may be a petrol car or basically fuel car or hybrid car or EV. So if it is a petrol or EV or hybrid, you can have various models like Toyota, Nissan, BYD, many combinations, right? So even you can have a five-seated, seven-seated, and five doors, four doors, two doors, etc. Right? Various different type of doors, and similarly, you can have various combinations. If you have going to have combinations, the first you will have three categories, and then you will have either fuel or hybrid, and then you will have different versions. Think you have five models and three into five, and if you have another different condition three and another different condition three, you have to multiply each five into three into three into three, and you will get the test case count. But it's a large number. So there are in real world there are various combinations coming in, and you have to test for a large amount of combinations to avoid. So you might know, if you have done the maths, you have done the NCR and calculate these numbers, right? So conditions, right? So you have various conditions, right? But it won't be practical. So because of that, there are concept called pairwise testing that we call pairwise algorithm. We use the pairwise algorithm to have the minimum number of test cases. So that's another concept. There are various scientific models, but I'm not going to deep dive into these models. There are various models. You can use it and you can find out. But basically, the five design techniques I mentioned are key. Any design concept or any technique, any algorithm will use them. So in addition to that, you can use a mind map. And if you like to learn a little bit on this design concept further, you can one thing you can try is pairwise combination, pairwise testing algorithm. Right? So that's also something you can try out basically. We call pairwise testing. So this what, right? You can you can Google it, or you can use ChatGPT and try to find out what is pairwise and learn a little bit if you want to put bit on research on it, right? But basically, you need to know the basic uh, testing techniques that I mentioned right now. Give me a second. Right. Okay. This is one another example that I would like to share. So this is sample scenario. Username is mandatory. Right. Login page. There's a username is mandatory. Username accept all email addresses. Password mandatory. Password can have 8 to 16 characters. And when user click on login button, you should be able to log to the home page. The from credential are provided, it should get email credential. These are the requirements, right? Basically, requirement will get like this. Maybe login page like this. So how could you use the design techniques and derive it? So basically, these are such startup samples. I'm not deep dive now, but I will share the slide deck all with you. So these are the way I derived. So based on the decision table, I can find out few test cases. Based on the equivalent partition, I can find out few test cases. Bound value analysis, I can find few test cases, right? State transition, I can write another set of test cases. Using design techniques, we can write. This is for sample. I will share with you to try out your own. I'm not going to deep dive it now. But this is sample, right? So basically, the requirement is like this. The assignment is like this, and you have to do this, right? So you can based on the record. If we are, I will take one small example. Password can be have 8 to 16 characters. Basically, we can have a boundary value for 8 and 16. Basically, we can test for 7, 8, and 9, and we can test for 15, 16, and 17. So these boundaries are support something like that. So similarly, we can have multiple different techniques and use the test design techniques and find out the number of test cases we need. So this is basically on the test case writing part of it. This is the template we use. Yeah. So that's the template as I mentioned. So do you have any questions still now or before we move to the next part of it? Basically, these test design techniques are very essential to make sure we write the correct test cases. Right. So next one is the test execution. So basically, once you write the test cases, and when application is developed and ready, you can start the test execution. Execution can be done either manually or either automated tool. If you automated already your test cases, so we'll see how to automate in future sessions. But if you have done automation already, you can execute automatically. Or if you haven't done any automation test cases, you have to run it manually. So there's a two-way of execution. So if you are running automation, see there are various. You can use Cucumber, Selenium, JMeter, Creative, different various things, right? There are various open source and proprietary tools. So based on your organization or based on your wish, you can decide which tools you can use it. Right. So basically, the execution. So our expectation is once you execute the test cases, you should be able to find out a defect. So as I mentioned initially, so once you execute defect, once you execute test cases, so I will come back to the initial slide. So you might remember this, right? Once we executed, we have to capture the actual results. So expected result is green color tick should be displayed. So if your actual results also a green color tick is displayed, is something like that, actual result and expected results are equal. But thing, so you could not able to uh, get the actual results as it is, right? So think your actual result is green color tick should be displayed, but you are getting red color tick. That means it's saying your username is incorrect, though you entered correct. So then actual results and expected results are mismatched. Basically, actual results are not equal to uh, expected result. So if that's the case, so we call it a defect. So if your actual results are not matched when we are executing your test cases against the application, if you are getting incorrect test cases, if you are getting incorrect test cases, sorry, incorrect results, that is not matched with expected result. So if there are difference between expected and actual results, we call a defect. So then we need to raise the defect against the requirement. So basically, if this is not matched, we call it a defect. So that's the fundamental requirement of software testing, because we need to find out the defects as much as possible, right? So that's basically the scenario, right? Right. So defect is the key fundamental outcome of the software testing. That's why we write the test cases. That's why we do the execution. By doing that, you need to find out the defects. So defects is the primitive outcome of software testing. A defect or bug is something we call defect, right? So we call some mismatches in actual and expected result. Right? So that's how, as I mentioned, if you find posting a difference in bit actual and expected result, we call it bug. So if you find a bug, you need to report it. So basically, we use different tools to report defects like Jira, Bugzilla, Redmine. There are various tools, open source and proprietary tools. You can set it up these tools in your organization and report these defects. Defects has its own life cycle. Right? It has its own life cycle and it has its own characteristics. Basically, defect should have a very clear description, and it need to be mentioned it's a defect. We need to have a priority. We need to have a severity for defect. We should have a status, whether it's open, fixed, closed, something like that. Severity is very essential. The product, the components, environment, and test phase we reported, and all these scenario, expected result, actual results, all these information should include, and you need to attach the logs or screenshots as evidence as well if you are reporting a defect. So defect is a fundamental requirement that we need to derive based on the test results, right? So these are few samples, and defects has two different type of characteristics, status. So one is severity. Severity means how critical defects is. So think if it's a showstopper, so you can't continue your testing, we consider as a critical defect. You can't think if we have started testing and it got crash, you can't do anything. So it's a showstopper, we call critical defect. Or there are defects, there are some of functionalities are not working. Few modules are working, but few modules are not working. So then some of the modules can test, but major few modules are cannot test. So we consider as a major defect, or sometimes we call high defect. But there are some situations, functionality is working, but you are getting some error message, unnecessary errors or something that, but you can cancel and continue. That means there are issues, but there are workarounds same time. You can cancel your error message and you can continue. So then we consider as a minor or medium defect. Sometimes there are defects, maybe they are UI label or other colors. So then we call it a low defect. So basically we have severity, something called severity. Severity define that defects how much severe to the application. If it's a critical failure, so we consider as a critical or showstopper. If it is a high failure, then we consider as a high or major. If it's a medium one, we call minor or medium. And if it's a low, very cosmetic defects, we said it's low. So based on the severity, people will attend. So critical defects has to consider criticality of high. So same time, there's another status called priority. So priority is basically we have medium, high, medium, low. So sometimes some critical defects will be very high priority because you need immediate fix to continue your testing. Sometimes some low defects even high priority. Think your organization logo color is incorrect. So this is a low defect. It's a cosmetic. It's a logo error. But organization perspective, it's a they are losing their reputation, they are losing their brand name. So because of that, they have to quickly fix it. So then, though defect is low severity, impact is low, priority will be high. The developer has to quickly fix it, right? So this, there are some scenarios, there are high critical defects. Sometimes severe priority will be low because you can live with these defects and you can fix it later. So the priority and severity is one of essential two criteria we need to measure when we are rating defects. So low priority, low severity defects are negligible. The high priority, high severity defects are the most crucial, but sometimes there are high priority defects, but low criticality. Sometimes high severity defects, but low criticality. So based on this graph, developers will attend these defects. So high priority, high critical will first, and then high priority and low, and then high severity and low. That's how we will be attending the defects. And defects has their own life cycle as well. Initially, we will start from new and will assign to the developer. So then developer will again, it will be make it open, and once he fix it, he will mark it as fix or resolve, or either he can decide it is duplicate defect, rejected or deferred or could not reproduce, because defect is not valid. It duplicated. Already there's a defect. Or defect is not valid, then he can reject it. Defect is valid, but he can't fix current release. He will going to fix it next release. Then it will be deferred. Or developer can't reproduce these defects because it's reproducible. Some reason they test raised, but now it is not appearing. So various, or either he can fix it or he can close the defect like this. So once he fixes it, he has to send it for the retest. The QA has to retest. So once he QA retest, they can verify and close it. If it is working fine, they can close the defect. But if in case defect is not fixed yet, then QA has to reopen and assign back to the developer. Right? So basically, this is the high level workflow. So start with new, then it will be assigned to the developer. Developer will keep it open and then he will fix the defect. Once he fix, he will mark it as fixed. But if he can't fix because of duplicate or it's not available, incorrect defect, or it's not going to fix this time, or he can't reproduce, then he will close it like this with command. And if he's fixed, then he will send for a DO tester to test. If it is fixed, actually it's fixed, then he can verify and close. If it is not really fixed, then he is reopening and signing. So this is a basic life cycle. So this life cycle we have to maintain in our defects. So to maintain defects, so we have to use defect management tools. Right? There are certain tools, Jira, TestRail, Redmine, Bugzilla. There are many tools, right? So Jira is one of popular one, but there are many other tools as well. You have to use these tools. Right. So I think this is what I covered already. Okay. So basically, so if you look at test, so test execution, so test case writing is the most essential part. To write test cases, you need to use the test design techniques. Write test cases, you need to do test design techniques, and then you need to once you derive the correct number of test cases, you can have the application as well. You can start as execution. Execution will happen either manually or automatically. If you are going to do it by manually, you can manually monitor the results and document it. So if there are mismatches in results, actual and expected results, we call it as a defect or bug. So if it is a defect or it's a bug, then we need to report it. To report defect, there are certain characteristics, certain criteria we need to tell the description, steps to reproduce, actual result, expected result, environment you test, what's its severity, what's its priority. All these things you have to report. So next thing is, so if once you are reporting, sometimes. So as for the defect life cycle, you will get rejected. So, but QA might not agree these rejected defects. They said those are not valid rejections. Those are actually defects that need to be fixed. So then firefighting might be started, right? QA will come and tell this is a valid defect. Developer will come and say no, it's not valid defect. So then to avoid that, these firefightings, we need to triage defects. We call triage. So basically, triage need to happen every day. They should have meeting with developers, QA team, business analysts, BA team, project management team. Everybody need to get together and discuss all the concerning defects. If everybody is agreeing, there's no issue. But there are defects, some party cannot be agreed, has to be discussed and agreed whether it's a defect or not. It's a collaborative agreement, right? Once we everybody agreed it's a defect and has to be fixed, then developer has to fix. If everybody agreed it's a wrong defect, then QA need to accept that's a wrong defect. Based on the root cause, they need to correct the test case or update the test case or correct the execution. Right? They have to correct it. So that's how it will be. So this triage meeting will decide whether these defects are, how we are going to attack these defects, how we are going to work with these defects, and whether we are going to reject and all that. Independently, nobody can reject or nobody can accept if everybody is not agree. It's a common understanding. These defect triage meetings are very essential because this is the place where we are going to decide how our application quality and how we are going to fix it and how we are going to retest and all this information. Okay, so when it comes to the defect fixes, you need to retest, right? This retest phase has few other activities. So either you can retest only your defect. So think you have few defects, very straightforward, very clear. You can retest those defects and you can pass these failed test cases. Straightforward. But there are certain scenarios we call confirmation testing. But certain scenarios, due to these defect fixes, many other places might impact it. Because of this code change, some of other functionalities might get impacted. So then problem, by testing or by retesting this defect, you can't make sure other functionalities are working fine. So then you have to identify the impact areas. So that's why this defect triage is very essential. Developer has to tell these code levels are impacted. Because of that, these functionalities got impacted. So then QA has to find out what are the related test cases for all these impacted functionalities. And they have to subset these test cases and execute. Not only execute the failed test cases, there are some previously passed test cases they have to select because of the code change, there are impacted areas. Right? So you have to find out these impacted areas and test it and do the we call regression testing. So previously we passed, but now we are testing again and again because the code changes done due to defect fix has impact of these other areas. So this information openly has to be shared by developers. If they hide this information, then developer will be end of the day responsible for lesser quality because people will get to know they didn't share this information. Similarly, if developer has informed this impact, QA has to make sure find out the exact impact test cases and do that regression. Whether you have enough time or not enough time is not something tolerate. You have to do that. Right? So this is one of essential requirement that we need to cover. Right? So defect triage, all these decisions will take at a defect triage. So that's why defect triage are very important in software development life cycle. So I think we didn't discuss what is defect triage, but defect triage are fundamental essential meeting we need to have regularly and making sure everybody agreed about defects and how we are going to fix and how we are going to test and how all these discussions has to be happen. Right? This is a one major critical thing that we need to consider during our development life cycle. Because end of the day, defects free product has to be released. Right? So that's why we need to do that. Any questions? Anything to clarify up to this point? Okay, if you don't have, we can move to the points to recap. So, okay, so the next thing is the exercise I would like to share with you all. I think this you need to try your own. So basically the same application I will be using. So you have been given 4 windows, right? 4 windows. So by looking at these 4 windows of the PickMe application, I need to find out, develop you to test 10 test cases covering all the design techniques, equivalent partition, boundary value, state transition, decision. So keep continuing this exercise because this will come up with as a, at one point it will be ended up with as assignment, right? So because of that, every week I am doing exercise, right? So that you need to continue your own because we will discuss and we will have a session separately at later. But if you continue right now, it will be easy for you to continue then finish your assignment very easily at one point, right? So because of that, every week what I'm going to give, try yourself, right? So if it's up to you. You can try it your own, or you can forget about it. But if you are trying it, you can easily do the assignment, maybe within few small time, maybe half an hour, 15 minutes, 20 minutes. You can complete the assignment and submit it. Right? So unless you might have to do all this hard work and late nights to complete it and deliver it, right? So rather doing it, you can do it very quickly. So this is an exercise. Try this. So develop 10 test cases covering these all four functionalities. I have marked it here. So you have to use equivalent partition, boundary value, state transition, decision hierarchy. So I already shared this slide deck with the LMS. I think you all have the LMS, and I shared the enrollment key as well. Use that enrollment key and log into the LMS. So this material is already there, so you can start immediately from today onwards. Right? So, and there is more quiz to recap what we have discussed today. I think I don't have many more thing to do today, so a little bit shorter session. So you can try this quiz. So make sure you do this quiz because this will help you exam, right? So the previous one it will help for your assignment, and this will help for your exam, right? So because rather putting large effort at last minute, by doing day to day, you can very quickly do your exam because this subject will be easy one, and you can score more where marks as well. So tell you honest. So if you learn and if you come to my session and learn this thing, you can very easily get a higher score that will help for the higher GPA value, right? So this is a easy way to get higher GPA. So be active in the sessions so then you can get a higher GPA very easily, not like other sessions, right? Okay, so I have given few hints already to make it higher, get some higher results. This is a easier subject to use, right? Okay, so use these quizzes and questions I am doing every week, so then you can easily crack it. Right? Okay, so I think that's all for today's session. So I don't have anything to cover. So a little bit of shorter session. So let me stop the recording. I probably will upload later maybe make it a little bit smaller version. If you don't have anything, I think we can wind up the session as well.